All right, so in this video, I'm just going to go over how to do each of the problems from the homework. Give a little video explanation. So any of the ones that you're not sure of, you can just skip ahead in the video to go right to it, or just skip ahead to see what the final answer is. And if you got it wrong, go back and check the work, whatever you want to do. All right, so the first one you guys had to do was number 1. All right, and we have a quantity raised to a power, so we can do this by substitution. Since it's only squared, we could do this without substitution. We could FOIL this out, but just to practice substitution, let's do it by substitution. All right, so I'm going to take u as my inside, which is 3 minus 4x. And then I'm going to do my du, which is negative 4 dx. All right, and we need to have all of du needs to be inside of our integral. We have a dx, but we're missing a negative 4, so we need to put a negative 4 there. But whatever we put on if we add a constant, which you're allowed to do, can't do variables, just constants. If you put one on the inside, you got to compensate by doing the reciprocal on the outside, which is negative 1/4 integral of. So this is all replaced with a du. And then this is my u, so it's u squared. So negative 1/4 integral u squared du. We now integrate and get negative 1/4 u cubed over 3 plus c. So I get negative, I replace my u with 3 minus 4x to the third power, all over 4 times 3, which is 12, plus c. All right, and there's our answer for number 1. All right, number 2. All right, so now this is not a quantity raised to a power. It's not trig. We just have a bunch of different terms. So we're going to do this. Now, I know everything we've done is substitution, been doing in the last couple days of notes. What's going to happen, they're going to be intermingled with ones we've already done before. So this is just how we would normally integrate. X cubed is just x to the 4th over 4. All right, this is really the same thing as x to the 1/3, right? So it's going to be minus x to the 4/3. Then we take the reciprocal of that, so it's 3 over 4. Now this one is the same thing as 3x to the negative 2nd, which is, I'll do this up here, that's 3x to the negative 3rd over, negative 1st, negative 2 plus 1 is negative 1, over negative 1, and we just move that to the bottom. So it's minus 3 over x plus 2x plus c. So there was no substitution in this one. We just did this like we've done in the past. All right, just like we did with derivatives, we would go over how to do like product rule, product rule, and then they get all mixed up. All right, so even though a lot of the ones on this page are substitution, there are a few that we're going to do like old school, like the way we just first learned a week or so ago. All right, number 3. All right, we have a trig function. When we just have one trig function and there's something that's not just an x, we always have to do substitution. And you're going to make u, we got one trig function, whatever comes after our trig, which in this case is 5x. So that's going to be our u. U equals 5x. The derivative of 5x is 5. We put the dx there. All right. So now this needs to be inside of my integral. I have a dx. I don't have a 5. This 5x is my u. It's not my 5 I need. So I have to add in a 5, which means I put a 1/5 on the outside of my integral. This is my du, so that gets replaced with a du. Secant squared, but it's not x, this is u. So I now just integrate 1/5 integral of secant squared u, which is 1/5. The integral of secant squared. Which one of the trig functions, when you take the derivative of it, do you get secant squared? It is tangent. So it's 1/5 tangent u plus c. But what's my u? My u is 5x. So 1/5 tangent of 5x plus c. Now remember, you can always check this by taking the derivative of this. All right, so you would have to use chain rule. The derivative tangent is secant squared. Keep the inside the same, 5x, times the derivative of the inside. The derivative of 5x is 5. 5 times 1/5 cancels out, and you'd be left with secant squared 5x. So if you ever wanted to check, you can always take the derivative of this and check your answer. All right, number 5. Another trig one trig function. So we're going to make u whatever comes after it, which is x squared. So our u is x squared. We take the derivative of that, and we get 2x dx. All right, we need all of this to be inside the integral. So I have dx, good there, it's taken care of. I have an x, so that's taken care of. I need a 2. All right, so now since I put a 2 there, I need to add a 1/2 on the outside. So the 2x dx becomes my du, right? So now this is all gone. I've substituted that already. Now I just need sine x squared, which is just really sine u. All right, so what is the integral of sine u? All right, so if you have all, might not be a bad idea to have all your derivatives written out. Look on the right side. Well, the derivative of cosine is negative sine, which means the integral of positive sine is going to be negative cosine. U plus c, and then I just replace negative 1/2 cosine u is x squared plus c. Once again, if you took the derivative of this, you would end up with what you started with. All right, so what was the next one we had to do? We had to do 6. Okay, now we have 2 trig functions, but they are to the same power. There's one here, they're the same. So we're still going to make u whatever comes after them. Notice it's the same. If they weren't the same, we would have an issue, but you're always going to be the same. So we're going to make u x cubed du, that's the worst d I've ever done, sorry. Du is 3x squared dx. All right, so we need to have all of this. Now remember, if there's no x squared somewhere in this problem, we can't do it this way. Fortunately for us, there is an x squared, so that's taken care of. There is a dx, that's taken care of. The only thing we don't have is a 3. So we got to put a 3 there. It doesn't matter where you put it. All right. So if I put a 3 inside, a 1/3 goes on the outside. So this is all gone. This is all gone. That's replaced with a du, because that's what 3x squared dx is equal to du. Now I have cosecant u, because that's what x cubed is, cotangent u. So I now integrate. So I got 1/3. So what's the integral of cosecant cotangent? Which one of our trig functions gives us cosecant cotangent? It is cosecant. However, those are opposite of each other, so it needs to be negative 1/3 cosecant u plus c. So it is negative 1/3 cosecant u, which is x cubed, plus c. And once again, if you wanted to check your work, you can take the derivative. Derivative of cosecant is negative cosecant cotangent. It'd be negative cosecant x cubed, cotangent x cubed. Take the derivative of the inside, which is 3x squared. The 3 cancel out, and you'd be left with this guy. All right, so it all works out perfectly. All right, for number 7. Now we have something underneath the square root. All right, so it is inside. So this is x squared minus 3, really to the 1/2. So what's on the inside? What's going to be our u? It's going to be x squared minus 3. My du is going to be 3x dx. There's my x, there's my dx. What am I missing? I'm missing a 3. So I put so all of this and that, right? This is my du, all right? So that's what gets replaced. So my integral, I add a 3, so that means I get a 1/3. All of that is du. So this is all gone. Now I'm not going to write it as the square root of u. I'm going to rewrite it as u to the 1/2. And then when I integrate, I get 1/3 u to the 3/2. Whoops, it's an awful 3. And then the 3 goes on the bottom, the 2 goes on top. So I'm left with an answer of 2, parentheses, what's my u, x squared minus 3 to the 3 halves over 3 times 3 is 9 plus c. And there's my answer. All right. Now, moving on to 8. 8, there is no quantity being raised to anything here, right? There's no trig. This is the kind we've done before where you split this up and you split this up, and it's going to be 2 terms. This is really the integral x to the 6 over x squared is x to the 4th. 5x squared over x squared is 5. All right, so then you just have to integrate each of these. You get x to the 5th over 5 plus 5x plus c. And there is your answer. All right, that's all you have to do. So that one's not a substitution one. That's one that's just like a normal one we've done before. All right, last 2 that you guys had in your homework were 11 and 12. So 11, we have something that's underneath a root, a radical. That's our inside. Remember, this is the same thing as 5x minus 2 to the 1/3. All right, so we make the u, whatever's on the inside, and that's 5x minus 2. The derivative is then 5 dx. I'm going to go ahead and I have my dx. I don't have a 5. So that right there is my du. I get 1/5. This is u. So it's u to the 1/3 du. All right. So then I have 1, when I integrate, 1/5 u to the 4/3. And then the 4 goes on the bottom, the 3 goes on top. And my final answer, I have a fraction. On top, I have a 3. And then my u is 5x minus 2 over 4/3 over 20 plus c. All right. Last one. Trig 1. One trig function. Hopefully getting the hang of these now. U is whatever comes after the trig. It is 2x. The derivative of 2x is 2dx. I have to add a 2 in there. This, remember, once again, this 2, you can't use this 2 because this is my u. All right. So that's my du. So I can rewrite this as 1/2. Why is the 1/2? Because I put a 2 in there. Got to compensate by putting the reciprocal on the outside. Cosine u du. And what is the integral of cosine? The derivative of what is cosine? It is sine. So 1/2 sine u plus c, and you just go back and replace it. So 1/2 sine of 2x plus c. And there is your answer. All right. Hope you guys did okay with this. If not, we'll continue to do more practice. Go back and watch the explanations again. If you have to go back and watch the notes again to try to help you out. We will be doing one more day of notes with this. I probably will sometime next week, maybe have a Zoom session for anybody who needs extra help. I can answer some specific questions that you have in real time. All right. Hope you guys have enjoyed your weekend, and I'll talk to you guys soon. All right. Bye.